Good morning. Welcome to the second in a series of 4 webinars on developing a Part 2 wellhead protection plan and presented by the Minnesota Department of Health and the Minnesota Rural Water Association. While you may have attended last week's webinar related to an overview of the wellhead protection planning process, this morning's topic will be an in-depth discussion and review of the data element component of wellhead protection plans. Also, please consider attending the next 2 webinar events in the series as well to hear more about the requirements for completing a potential contaminant source inventory and developing well-written management strategies. Staff presenting today include myself, Robin Haar, from the Minnesota Rural Water Association to provide an introduction to the topic of data elements, Pat Bailey from MDH to provide information about the use of data elements during Part 2, Chris Parthen from MDH with information pertaining to how vulnerability of a DWSMA can impact data elements in the Part 2, and Amanda Strummer from MDH to give some practical examples of the application of the data elements in Part 2 plan writing. Again, my name is Robin Haar, and I'm a Minnesota Rural Water Association groundwater specialist, and it's been my pleasure to assist public water supply systems in Minnesota with both wellhead protection plan development and implementation for the past 16 years. Today I plan to provide an introduction to the topic of data elements, such as what are data elements, where does the requirement to gather them for the wellhead protection plans come from, which ones do we need to put into wellhead protection plans, and what should we do with the data elements when developing the Part 2 wellhead protection plan. So, just what are data elements? I think all of us who have written wellhead protection plans for public water suppliers have stopped to ask this question to ourselves. We're left to determine what data elements are as they relate to the development of the wellhead protection plan. Put simply, data elements are pieces of information in the form of maps or data lists, descriptors, and summaries. This isn't a finite list, but you get the idea. While there seems to be the potential to have infinite data relating to a DWSMA, the wellhead protection rule only requires that existing information be gathered and assessed. This information can be found in federal, state, and local databases, or even gleaned from public water supply staff's own knowledge and experiences, such as when locating sources that may contaminate the public water supplier's drinking water supply during the Potential Contaminant Source Inventory, or PCSI. Much of this data is available in the public domain on the Internet, such as many well locations on the County Well Index, or tank and leaking underground storage tank sites on the Minnesota Pollution Control's What's in My Neighborhood site. Some data may be available in regulatory program files, such as County Sanitary Sewer Treatment System inspection records. Later in this presentation, Pat Bailey will introduce a new plan development tool to you that provides some specific information about where many of the required data elements can be found. After we've taken the time to gather all of the required information, we need to put it to work. It's been my personal experience that it's tempting to want to hurry through addressing the data elements because the process seems abstract. The data elements are pieces of information like a big puzzle. If time isn't taken to look at each piece and put them together, we'll never be able to see the big picture. The information contained in the gathered data elements are the foundation for the following steps in Part 2 planning process. They shed light on various issues, problems, and opportunities the public water supplier may have, and they begin to provide the scientific rationale behind the plan of action developed for the management of the DWSMA. As you are well aware, the world is awash with data, so how are you to know what particular data will be required to be used for the Part 2 wellhead protection plan? Well, the Minnesota Wellhead Protection Rule states that the MDH will determine which data must be contained in the wellhead protection plan and used to prepare the Part 2. This is meant to pare down for you as best as possible the data gathering requirements so you're not spending a lot of time trying to determine for yourself what information might be useful. The MDH, as a regulating agency, is required by the Minnesota Wellhead Protection Rule to hold an official meeting where the data elements for the Part 2 are identified. You may know this as a Scoping 2 meeting. During this meeting, the MDH planner will provide and review the Scoping 2 decision notice as one of the major talking points of the meeting. While the Scoping 2 notice is only in draft form at this meeting, the official copy is mailed to the public water supply system within 30 days of the meeting. The notice specifically identifies which data elements are required to be considered when developing the Part 2 plan. Some data elements have already been gathered for the delineation and vulnerability assessment in Part 1, and they don't need to be gathered again. The notice also provides direction on what data elements information must be submitted to the MDH with the Part 2 plan, and what data elements must only be considered and assessed but not submitted to the MDH with the Part 2 plan. The description of these particular designations can be found on the front page of the Scoping Decision Notice and are circled here in red. It's important to realize that the Scoping Decision Notice, for all intents and purposes, doesn't change. Virtually all of the data that may be required for the development of a Part 2 plan can be placed in the categories of data that are in the form already. Therefore, a category of data may not be required to be considered for this particular wellhead protection plan due to the vulnerability setting, for instance. In this case, the N box would be checked next to that data category. If the data is required to be used for the development of the plan or looked at and evaluated for its impact on how the PWS can manage the DWSMA, the R will be checked. This data is required to be kept in the PWS files but is not required to be submitted to the MDH with the Part 2 plan. Finally, if the S is checked, the plan must not only consider this data element with respect to its impact on the management of the DWSMA, but also be included in the Wellhead Protection Plan. Usually this is data that is either not located in the public domain or may be in data sources that are not accessible to the MDH. The Minnesota Wellhead Protection Rule states that the data elements identified in the Scoping Decision Notice must be assessed by the public water supplier during the development of the Part 2 plan. When you set about to gather the required data, you may or you may not find what you feel to be an adequate amount of data related to the requirement. Also, the data that you do find may vary in its reliability. For instance, you may determine that the data is very outdated, or the data may have been gathered in such a way that the information can't be counted on to provide a clear picture. Finally, the data must be viewed in the context of how what is known about the data may relate to the management of the DWSMA. A particular piece of data may have a profound impact on how a public water supplier can manage the DWSMA, or it may have absolutely no impact at all. Noting either how the data may impact the DWSMA management or even the fact that the data has been evaluated and determined to have no impact at all are both noteworthy. Finally, the Minnesota Wellhead Protection Rule instructs us on what we should specifically assess the data for relative to the DWSMA. We're directed to look at each data element's present and future impact on the use of the well, delineation criteria, quality and quantity of water supplying the PWS well, and land and groundwater use in the DWSMA. Most of the discussion in the Part 2 plan may center around land and groundwater use in the DWSMA, since much of the impacts of the other components have been discussed in the delineation and vulnerability assessment, and also land and groundwater use is the most likely DWSMA management tool that's available to the PWS. It's also possible, however, that certain information may lead to impacts on how the PWS well is used, what future DWSMA delineations are, and even the availability and quality of water supplying the PWS well. There will be a more in-depth discussion of the assessment of the data elements later in this presentation by Chris Parson. At this time, I'd like to introduce Pat Bailey, MDH Planner, to the group, and she'll continue the presentation by providing good information about where to locate data elements in the public domain and some rationale for the requirement to collect and assess certain data.
Thank you, Robin. I'm Pat Bailey. I work for the Department of Health as a planner out of the Rochester District Office. My part of the webinar will be to talk about specifics relating to data elements and where you can find the information, primarily on the internet. Hopefully you have downloaded a copy of the data elements table that was available on the Minnesota Rural Water Association website. I don't have a specific slide showing the table, but we'll be referring to it. If you look at the table now, you'll note that it's comprised of 4 different groupings of data elements, and under each of these there are 4 columns. The first column states the data elements listed in the Wellhead Protection Rules section 4720.5400, or a summary of that information. The second column suggests where you can find the specific information on that data element, primarily on the internet. The third column indicates in what vulnerability settings these data elements apply, and the fourth column provides the purpose or value of this information in the Part 2. The rule categorizes the data elements into 4 areas. These are shown on the table as the headings, and they are physical environment, land use, water quantity, and water quality. Physical environment data elements describe the drinking water supply management area in regard to physical characteristics that include precipitation, geology, soils, and water resources. Land use data elements provide detail regarding the location of the DWSMA in reference to local government jurisdictions, zoning and land use planning areas, public utility services, and the potential contaminant sources. Water quantity data elements relate to how much water there is in the DWSMA, who is using it, and possible water use conflicts. Water quality data elements relate to the water quality of the groundwater and surface water in the DWSMA, location with past contamination incidences, and possible risks posed by these to the source water supply. Looking at the physical environment data elements, the first one in the rule deals with precipitation. Precipitation data is only required in high vulnerability settings. The data may be available to you from the municipality that you're working with if they have a wastewater treatment system and are required to keep precipitation data as part of their discharge monitoring reports that they send to the Pollution Control Agency. Another source of information is the Minnesota Climatology Working Group, as shown in the slide here. They have this application that creates annual summaries of precipitation data gathered by volunteer-based observation networks throughout Minnesota. The data presented are monthly totals, and the data is grouped by county. Observer locations are described in regards to township, range, and section numbers. So it is likely that you can find an observer in a 5-year record close to the community that you are working with. Information about the geology has already been brought together and reviewed in delineating the wellhead protection area and in assessing the vulnerabilities of the wells and the DWSMA. Therefore, referring to the conclusions from the Part 1 and the references provided in the Part 1 document, such as this cross-section figure, is typically sufficient for the Part 2. Soil condition information is required in high vulnerability settings. Many Part 2s that I've looked at that were done in the past would include soil maps scanned out of a hard copy of a county soil survey book. This can be done, but obtaining useful information from these maps may be difficult. Now, today we have the Web Soil Survey online, which provides soil data and information that is electronic. A soil map specifically for a DWSMA can be easily generated through the Web Soil Survey application if you have the shapefiles of the DWSMA. Going to the Area of Interest tab in the Web Soil Survey, you can upload the DWSMA shapefiles creating an area of interest, and the program will generate soil maps and reports with detail on percent of each soil units in the area, or in the DWSMA. Also provided are profiles of these units regarding information on slopes, natural drainage class, land capability classification, which includes erosion information. The program can also be explored to find information on the hydrologic soil groups. These groups are based on estimates of runoff potential and rate of water infiltration, which in turn relate back to the soil condition data elements in the Wellhead Protection Rule. These reports and maps can be downloaded as PDF files. The data elements grouped under water resources all relate to surface water resources and their management. There are various places on the web where you can obtain information. If you are looking for GIS data on watershed boundaries, public waters, and floodplains, Minnesota Geospatial Commons, as shown here, has replaced the DNR Data Deli for the place to go for this type of information. You can query the website by category or organization to drill down to what you need. Also, public water inventory maps and lists by county are available at the Minnesota DNR web pages referenced on the data elements table. However, related shoreline classifications would have to be obtained by looking at the county and or city ordinances for the area you're interested in, and then these would reference back to the public waters as determined by the DNR for that county. Shapefiles of the wetlands map during the National Wetland Inventory are also available through the Minnesota Geospatial Commons. Another place you can obtain information about wetlands that have been mapped through the National Wetland Inventory is at the U.S. Fish and Wildlife Service National Wetland Mapper website. From this website, you can print a map of the wetlands in and around the DWSMA that you're interested in. In the case of a highly vulnerable DWSMA, the water resource data elements would be required to be used in the plan. However, if there are no lakes, streams, and or wetlands in the DWSMA, then obviously the related data elements do not exist. If this is the case, then that should be noted in the Part 2. Much of the land use information under this category will be available only from local government units. Some counties and cities have zoning maps and comprehensive land use maps on their websites, but you may have to obtain hard copies of these maps from the jurisdictions. Also, the community you are working with would have to provide sewer maps, storm sewer maps, and public water system maps if they are required to be in the plan. It should be emphasized that the public water supply system maps do not have to be included in the plan if there is a security concern on the part of the public water supplier. The community you are working with may be able to provide you with parcel maps. Also, you may be able to obtain parcel coverage for your DWSMA from county GIS staff. In addition, many counties have access from their county website to GIS online interactive mapping programs that are either hosted by the county or through a site like Beacon. The potential Contaminant sources that need to be inventoried and mapped are under the land use category, but this data element will be covered in detail in the next webinar, so we are not going to spend any additional time on it now. The next category of data elements are water quantity. So there are surface water quantity ones and groundwater quantity data elements. The surface water quantity data elements are only required in a highly vulnerable DWSMA. Relating to permitted withdrawals, water appropriation information can be found at the DNR Water Use Water Appropriation Program webpage, and this link is given in the table. Discussion regarding the concept of protected flow can be found by following the link in the table as well. From this page, there is a link to stream flow reports. There are two types of reports and maps. Weekly stream flow reports and maps are created April through September every year and are up to date. Annual stream flow reports are an average of flow conditions for a specific water year, and this data is available for only those years 1977 and 1985 through 2002. Discussion of ordinary high water levels for lakes is available following the links provided on the table. Ordinary high water level reports are available for some individual lakes through the DNR Lake Finder. If there are specific questions related to these surface water data elements, it would be of value to contact the DNR area hydrologist for more information on the water bodies you are interested in. In addition, if the public water supplier believes there may be a water use conflict, it would be useful to discuss this with the DNR area hydrologist as well. Like the water resources data elements, if there are no lakes and streams in the DWSMA, then there would be no information on protected flow or ordinary high water levels. In some cases, even if there are lakes, the ordinary high water level may not have been established. At any rate, if there is no information or there are no lakes and streams, this should be noted in the Part 2. Information on water appropriation of groundwater can be reviewed at the same DNR web pages as mentioned for surface water appropriation. DNR also has a groundwater level monitoring program. This program involves a statewide network of water level observation wells, or what are called OB wells. These wells and the data available on water levels from these wells can be explored by going to the web pages listed on the data elements table for this section. This graph or hydrograph was generated from the data collected from one of these wells. The graph shows the fluctuations of groundwater levels over time. If it is thought that there have been well interference issues and water conflicts in the DWSMA, the DNR area hydrologist again should be contacted to discuss this. Like surface water quantity data elements, surface water quality data elements are only required in highly vulnerable settings. If there are streams and or lakes in the DWSMA, the place to check to see the water quality management classification is the MPCA Rules Chapter 7050. Water quality data on streams and or lakes could be available from many different sources, but the MPCA Environmental Access Database is a good place to look, and the link to that is on the data elements table. Groundwater quality data from the public water supply wells would have already been reviewed for the Part 1. And also at that time, they would have determined whether there was any isotopic data in the area and groundwater tracer studies. However, there might also be water quality data available from other wells in the DWSMA. This data may be available from sources including the Pollution Control Agency and the Department of Health, or locally from county public health or environmental services departments. The best place to start looking for information regarding groundwater contamination and spills and releases is the Pollution Control Agency's What's in My Neighborhood website, which is shown here on the slide, and the Department of Agriculture What's in My Neighborhood Ag Interactive website for information specifically related to incidences of contamination from fertilizer and pesticides. So in closing, hopefully the data elements table, will help you in the future find the information you are requested to gather. The next step will be to assess the information and see if it is providing you with insights into land and water issues, problems, and opportunities in the DWSMA. The background of why the information is being requested for the Part 2 is discussed under each category in column 4 on the table. Now Chris and Amanda will be providing more detail and examples of when and how this information is used.
Thank you, Pat, for the information on data elements and where to find them. Hello, everyone. This is Chris Parthen. I'm a source water protection planner out of the Bemidji District Office. And let's move on now that we understand data elements and where to find them. Let's investigate how vulnerability affects their use in the wellhead protection planning process. Thank you, Pat. Appreciate the information on where to find those data elements. This is Chris Parthen. I'm a planner up in the Bemidji District Office, and we're going to move on and investigate how vulnerability affects their use in wellhead protection plans. Thank you, Pat. We appreciate the information on finding data elements for wellhead protection plans. Hello, everyone. This is Chris Parthen. I'm the principal planner out of the Bemidji District Office, and we're going to investigate how vulnerability affects use in wellhead protection plans. Thank you, Pat, for telling us how we can find some of those data elements out there in the real world. Hello, everyone. This is Chris Parthen, principal planner with the Minnesota Department of Health, and we're going to investigate how vulnerability affects data elements use in wellhead protection plans. Thank you, Pat, for the information on where we can find those data elements to place into our wellhead protection plans. Hello, everyone. This is Chris Parthen. I'm the principal planner out of the Bemidji District Office, and we're going to investigate how vulnerability affects data elements and their use in wellhead protection plans. Thank you, Pat, for that discussion on data elements and where to find those for use in our wellhead protection planning process. Hello, everyone. This is Chris Parthen. I'm a principal planner with the Minnesota Department of Health out of the Bemidji District Office, and we're going to investigate how vulnerability affects the use of data elements in the process of developing a wellhead protection plan. Thank you, Pat, for that information on data elements and where to find them. Hello, everyone. This is Chris Parthen. I'm a principal planner out of the Bemidji District Office with the Minnesota Department of Health. And let's investigate now how vulnerability affects data elements use in the wellhead protection planning process. Vulnerability assessments are a foundational component in the development of a wellhead protection plan. Vulnerability is assessed by the hydrologist during the development of Part 1 of the Wellhead Protection Plan and must consider three important parameters: geologic sensitivity, well construction, maintenance, and use, and water chemistry and isotopic composition. Geologic sensitivity refers to the ability of the Earth's geologic materials to protect a well or well field from contaminant sources as determined by vertical travel time. Shorter travel times mean the geologic sensitivity is greater, whereas longer times indicate a lower geologic sensitivity. The Part 1 Wellhead Protection Plan is required to include a description of the hydrogeologic setting and the geologic conditions that occur throughout the DWSMA between the land surface and the aquifer used by the public water supplier. Well construction, maintenance, and use are important characteristics in assessing vulnerability, as they determine whether the well may serve as a potential pathway for contaminants to enter an aquifer. Improper well construction or maintenance may provide pathways between near-surface water and deeper aquifers, effectively bypassing any natural geologic protection. Assessment of well construction and use also helps identify whether the public water supply well is potentially vulnerable to contamination because of construction practices and the well's state of repair. Use of the public water supply well is considered in terms of pumping and recharge rates. Pumping rates affect aquifer response and the time required for contaminants to move toward the well. As the pumping rate increases, more stress is placed on the aquifer in the area around the well and can increase the rate of vertical leakage across a confining layer and reduce the level of protection afforded an aquifer. Water chemistry refers to the occurrence of different chemical constituents dissolved in water, and isotopic composition refers to the atomic makeup of the water molecule itself. The presence or absence of contaminants or indicator parameters, isotopic dating of the well water, and changes in general water chemistry over time should be used to verify the other vulnerability assessment criteria, characterize the rate of recharge to the well, and to provide warning that contaminants are being introduced to the aquifer. Vulnerability is rated by the hydrologist during the development of Part 1 of the Wellhead Protection Plan and considers the same three important parameters: geologic sensitivity, well construction maintenance and use, and water chemistry and isotopic composition. The Minnesota Department of Health uses a vulnerability rating method where points are assigned for conditions that represent a potential risk to a well. The evaluation includes each of the three criteria previously noted where such information is available. Geologic vulnerability in an unconfined aquifer setting is rated based on the thickness of the vadose zone and the permeability of the units present. In a confined aquifer setting, geologic vulnerability is rated based on the cumulative thickness of the confining units and the permeability of the units present. Well construction maintenance and use vulnerability is rated based upon the level of casing integrity, the casing depth, the pumping rate, and the isolation distances from contaminant sources as specified in the State Well Construction Code, Minnesota Rules, Chapter 4725. Water chemistry and isotopic composition vulnerability is rated according to analyses of nitrate plus nitrate nitrogen, tritium, and quantifiable levels of either pathogens or other traceable chemical compounds that indicate groundwater degradation. Water chemistry contributes significant weight to assessing vulnerability and can confirm or deny the vulnerability derived from the geologic sensitivity in well construction, but ultimately trumps the conclusion derived from the other two parameters. Minnesota rules are very prescriptive regarding the data elements that can be selected to be used in a wellhead protection plan based on the hydrogeological setting and vulnerability of the wells and the DWSMA. Data elements that apply to the physical environment include precipitation, geology, soil conditions, and water resources. Data elements that apply to land use include parcel and political boundaries, a map and inventory of current and historical land uses and potential contaminant sources, current zoning requirements, and public utility services, which considers infrastructure such as transportation corridors, storm and sanitary sewers, pipelines, public drainage systems, and other wells. Data elements that apply to water quantity include surface and groundwater, and considers measured and or protected levels of public waters, permitted withdrawals from lakes and streams, and any known water use conflicts. Data elements that apply to water quality also include surface and groundwater, and considers water quality management classifications for applicable lakes and streams, lake and stream water quality monitoring data, water chemistry and isotopic data from wells, springs, or other groundwater sampling points, known areas of groundwater contamination, and any reports to the Department of Agriculture or the Pollution Control Agency of contaminant spills and releases. Since Minnesota rule dictates the data elements that must be considered in the development of wellhead protection plans, the same data elements are often selected and applied in the separate development of the Part 1 and Part 2 portions of the Wellhead Protection Plan. While this may appear duplicative at face value, it is important to recognize that a hydrologist developing the Part 1 utilizes the data element differently than the planner developing the Part 2. There are a couple of reasons why the same data elements are assessed differently in the development of a wellhead protection plan. There is often a time lag between the development of the Part 1 and Part 2 that can span 1 to 2 years. The data may have changed during this time lag, and it's important to capture and reflect the most current information regarding the data element. Examples of data elements that may experience change include precipitation records, land use, political boundaries, and parcel boundaries. Another reason why the same data elements are often assessed differently in the development of a wellhead protection plan is that the data elements are used for differing purposes. Data elements in Part 1 are usually used to assess well and aquifer vulnerability and for modeling purposes. Data elements in Part 2 are usually used for identifying sources of potential contamination and for developing the subsequent management strategies. This table identifies how data elements are used differently in the Part 1 development and the Part 2 development of wellhead protection plans. These examples include parcel coverage, which in Part 1 is used to determine the DWSMA, and in Part 2 is used to identify real-world locations for potential contaminants. Political boundaries in Part 1 are used to determine the DWSMA, and in Part 2 are used to determine the jurisdictional partners for plan implementation. Public utility services are used to determine leakage and recharge in Part 1 modeling efforts, and in Part 2, public utility services are used to identify potential contaminant sources. Groundwater quantity is used to model the wellhead protection area in Part 1, and in Part 2 it's used to develop a contingency plan for alternate water supplies. Groundwater flow is used to model the wellhead protection area in Part 1, and in Part 2 is used to help prioritize management strategies. And lastly, surface water quality in Part 1 is used to assess vulnerability, and in Part 2 it's used to develop management strategies. The use and application of the selected data elements is critical to the development of a pertinent Part 2 wellhead protection plan that accurately identifies effective management strategies over the life of the plan. Data elements and their assessments, when combined with recognition of problems and opportunities, and a thorough understanding of the impact of changes over the life of the wellhead protection plan, results in a productive environment in which effective management strategies can be identified and implemented. This can be visualized as a three-legged stool, where each leg is integral to the others, and where the three legs provides a stable platform on which to build management strategies that will address the identified issues and protect the drinking water supply. Data elements are foundational to assessing the vulnerability of a drinking water supply and providing direction to protecting that supply from contamination. In general, as vulnerability increases, there is a greater risk of contaminants being introduced into the drinking water supply, and a greater number of data elements will require assessment to gain a scientifically based understanding of the vulnerability. Higher vulnerability settings will also require inventorying and documenting increasing numbers of potential contaminants, and the amount and complexity of implementation measures to address those contaminants will realize corresponding increases. Now that we understand data elements and how vulnerability affects their use in the development of wellhead protection plans, it's my pleasure to turn the presentation over to Amanda Stromer, who will take what we've learned and apply it in a real-world situation.
Good morning. My name is Amanda Strummer, and I am a Minnesota Department of Health Source Water Protection Planner in the southwest part of the state. I've been with the Health Department since last August. As a way to think about all of the information covered by Robin, Pat, and Chris, We will now highlight some real-world scenarios of how the data elements are applied for both non-vulnerable and vulnerable geologic settings. I have two little girls at home. They are 5 and 2, and no, this is not a picture of them, but we read a lot of stories at our house. So since I am the newest planner, they gave me the easy job of telling all of you a story today before you get to eat your lunch. So once upon a time, there was a community named Pretendville. Pretendville is a charming community with a population of a little over 3,000 residents. There are 2 well fields. The city has 2 older wells that are 60 feet deep and are located in the southern part of town. There is a stream that runs near the wells, and these wells are highly vulnerable. They have high nitrates and chlorides, which indicate that there is a surface water influence to the wells. The stream flows from the west, near the lagoons, toward the wells. The community drilled wells 3 and 4 more recently on the north side of town, and those wells are deeper at around 300 feet. The vulnerability of those 2 wells are considered very low because they are constructed so that each well is adequately sealed into the borehole and does not pump water that contains human-caused contaminants. That is determined by evaluating the geology, soils, and groundwater chemistry. We know that there is at least 50 feet of clay which protects the lower aquifer. For each well field, you can see the locations of the emergency response area in red. This is the area where contamination or a water drop could move horizontally towards the well and reach the well in 1 year. The blue line is the Wellhead Protection Area, or WAPA, which is a modeled 10-year time of travel. Because the WAPA does not follow recognizable boundaries on the land surface, we create the Drinking Water Supply Management Area, or DWSMA, in yellow. This example allows us to dive into how we as the planners help the community look at the required data elements, which, as we learned earlier, is all dependent on the vulnerability. So let's start with the non-vulnerable well field up in the northern part of Pretendville. In the non-vulnerable area, you are not going to need to gather information about things like precipitation, soils, utilities, or surface water resources. Instead, the focus is on the geology, land use, and the quantity and quality of the groundwater. Much of the required data elements comes from the Part 1 Wellhead Protection Plan. The information from the Part 1 is required to be considered and evaluated in development of the Part 2, but it is not usually required to be submitted. It is important to review that information, and if you recall, I indicated earlier that this non-vulnerable well field has a good water quality and a clay liner. Besides the Part 1 plan, the main data elements that you will gather and consider in creating the management strategies include parcel boundaries, political boundaries with township section range, land cover, land use and zoning maps, and records of wells and borings. For the potential contaminant source inventory, you are mostly going to document wells and Class 5 injection wells. Make sure you pay special attention to the scoping notice and the depths of wells that should be included. This is a relatively new change, and we want to make sure you are paying close attention to the well depths and ranges listed on the Scoping 2 notice. The MDH hydrogeologist sets these based on what depth of wells could impact the city aquifer. The reason we do this is because there may be some shallow 20 or 30-foot wells in this area, but because we know that there is a deep clay liner, the hydrogeologist is using the data from the Part 1 plan to prioritize for us wells that penetrate into the deeper aquifer where the city draws their water. Because of the way plans are being written now, we want to prioritize and target the sealing of those wells which would have the most impact on the city's 300 feet deep wells. Grant funding is intended to go towards sealing those priority wells which are identified in the Part 2 plan. Looking at the groundwater quantity and quality gives you a good sense for where there might be issues. For example, if there was a high-capacity well at this industrial park just west of the DWSMA, we would want to know more about the appropriation permit or of any interference. But since we know that all water users in the city are required to hook up to city water, we can note and consider that within the plan. Now, when we shift down to the south, down to this highly vulnerable DWSMA, all of the aspects we discussed with the non-vulnerable situation still apply to this area. You still gather, consider, and submit those items. In this area, the DWSMA extends into the neighboring township. You still submit the local government boundary map, comprehensive land use, and zoning map because Pretendville now does not have control over all the land uses in this part of the DWSMA. If you recall, these two wells are 60 feet deep with high nitrates and chlorides. You must now consider how surface water may influence the wells. So you're going to be looking for precipitation gauging stations and looking at monthly and annual precipitation data. You will need maps and descriptions of the soils because knowing if the soil infiltrates at a higher rate or whether erosion and sedimentation is occurring along this creek can impact how possible contaminants may move towards the wells. In this situation, Pretendville Stream is a public water and the wells are in the floodplain, so you will need to gather and submit maps of the major and minor watersheds. You would also gather but not need to submit maps with the shoreland classification, wetlands, floodplains, drainage ditches, and other public waters. Since the wells are in the floodplain, there would likely be an ordinance that would need to be considered which would assist the city with the control of land uses in the floodplain. We would also want to have a map of all the transportation corridors, gas and oil pipelines, storm sewers, and sanitary sewers, because if a spill or leak happens, that could contaminate the wells. The potential contaminant source inventory for this area will be much more complex. Not only would you look for everything you looked for in the non-vulnerable area, such as wells, but you would also look for things like tanks, egg sites, hazardous waste sites, septics, stormwater, the list goes on. Because those things can have an impact on those shallow, unprotected wells. We know that we have high levels of nitrate and chloride in these wells. Those contaminants need particular attention since we know the well water quality has already been impacted by those contaminants. In this instance, as we gather and submit the stormwater maps from the city, we find that the storm sewers outlet to Pretendville Stream just upstream of the wells within the DWSMA. Because of that, we would want to think about the potential impact of that on the highly vulnerable wells. That might be a source of the chloride because over the winter, all the salt that is put on the roads in town washes directly into the stream. This entire upper watershed in the southeast corner of the map drains towards the stream right near the wells. We can get sources of nitrate from feedlots, septics, or fertilizer application in this area. Knowing water testing results and if the stream is designated as impaired can greatly inform plan development. We know that the stream runs past these wastewater lagoons from the west, east towards the wells. This is another potential source of chloride and nitrates. Combining the surface and groundwater quality data together with all the information you know about the land use helps to inform the steps the public water supply can take to protect and improve the quality of water in those vulnerable wells. Most of the time you need more data and a better understanding of that surface water-groundwater connection. You evaluate what you know with what you need to know and can create a series of management actions to help the water supplier begin to establish that relationship. It's important to evaluate the data for its relevance to the DWSMA. Keep in mind that sometimes you have multiple vulnerabilities within the same DWSMA. They are not always split apart like this example, but the same concept applies. When we review the final plan, we use the data elements to make sure everything that was required in that Scoping 2 notice is included in the final plan. Make sure that if you have to submit a map or other data, that the information is in the plan. It's very important that you double check this. It's so unfortunate when we have to deny a plan approval because something that was required to be submitted was not submitted. Also keep in mind that everything that we just covered is intended to make sure that as the Part 2 is developed, the information that you are pulling for the data elements goes into the management strategies in the plan. You don't just gather all the data to just have the data. You have to use it and apply it so that the community understands what the possible threats are to the water supply and what they can do to protect it. The next webinar will be focused on potential contaminant source inventory. The potential contaminant source inventory is where we can have a significant impact in figuring out what could impact the public water supply wells and how to protect them. The potential contaminant source inventory is also influenced by the vulnerability, just like it impacts the required data elements. Next week's webinar will go into more details about that, and we highly encourage you to attend because that is a critical thing we look at when reviewing and approving plans. In summary, data elements are pieces of information in the form of maps, lists, descriptors, and summaries. They are brought together and evaluated to shed light on the physical environment, land use, water quantity, and water quality. Data element requirements and assessments are based on vulnerability, and they document and help build effective management strategies. Be sure to use the data elements to inform the contaminant source inventory and to assist with identification of the issues, problems, opportunities, goals, and management strategies. This webinar was recorded, and you will be sent information about how to access this webinar at a later date. Information in this document is available in alternative formats to individuals with disabilities upon request by contacting George Meinrich. Thank you very much for attending this webinar, and please feel free to contact us if you have any questions.